9 more amazing facts about the solar system. Hi guys, once again we've delved into the hidden numbers of the solar system to uncover these oddities that make us appreciate even more the grand complexity and beauty of our cosmic cradle. In this wonderful video, we present 9 more decidedly instructive and fascinating facts. Enjoy your viewing. Earth is the only planet where fire can be lit. Fire is probably the first form of technology discovered by humans. Historical evidence suggests that humans started using fire about 1.5 million years ago, and it is likely thanks to this ability that they managed to control their environment and form the first social groups. The surprising thing is that Earth is the only planet with an environment suitable for fire. No other planet in the solar system can sustain a fire, not even the Sun. Strange, right? The Sun seems like a ball of fire, but what we see is not actual fire. It's an atomic reaction producing enormous amounts of light and heat, giving the Sun its fiery appearance. And what about the lava from volcanoes on other planets? Isn't that fire? Well, some planets like Venus or moons like Io have active volcanoes, but the lava erupting from these volcanoes is not accompanied by live fire. It doesn't burn, it's just heated and liquefied rock. To burn, fire needs 3 elements: molecular oxygen, heat, and fuel. Without one of these ingredients in adequate amounts, fire cannot develop. Ultimately, what prevents other planets from having fire is the lack of oxygen in their atmospheres and the absence of fuel, which on Earth comes from decomposed organic matter. Earth has all 3 ingredients in the right proportions, with the right temperature and pressure, making it the only planet capable of producing and maintaining fire. The Sun loses about 6 million tons of mass every second. The Sun loses mass in 2 main ways. The first is through the solar wind. The Sun's surface is hot enough to boil off electrons and protons, which then drift away from the Sun, creating a wind of ionized particles. When these particles hit Earth's upper atmosphere, they can produce auroras. The solar wind varies in intensity, but satellite observations show that the Sun loses about 1.5 million tons, 1.4 million metric tons, of material every second due to the solar wind. The second way the Sun loses mass is through nuclear fusion. The Sun fuses hydrogen into helium in its core, producing its life-giving glow for billions of years. The production of helium converts some of the hydrogen's mass into energy, which radiates away from the Sun as light and neutrinos. By observing how much energy the Sun radiates and using Einstein's equation that links mass and energy, we find that the Sun loses about 4 million tons, 3.6 million metric tons, of mass every second due to fusion. So, the Sun loses about 5.5 million tons, or 5 million metric tons, of mass every second, or about 174 trillion tons or 158 trillion metric tons of mass every year. That's a lot of mass, but compared to the Sun's total mass, it's negligible. The Sun will continue to shine for another 5 billion years, and by then, it will have lost only about 0.034% of its current mass. Although the amount of mass loss is negligible, it's not zero and has an effect on Earth's orbit. As the Sun loses mass, its gravitational pull on Earth weakens over time. Consequently, Earth drifts slightly away from the Sun. Due to the Sun's mass loss, Earth's distance from the Sun increases by about 0.6 inches or 1.6 centimeters per year. In astronomy, one way we measure distance is through the astronomical unit, traditionally defined as the distance from the Sun to Earth. For most of astronomical history, Earth's variable distance was so small to consider, so the astronomical unit could be considered a constant. But over time, our measurement of this distance has become incredibly accurate, currently to about 3 parts per billion. This is accurate enough to observe the gradual increase in distance. So in 2012, the astronomical unit was defined as a fixed constant. As a result, Earth is now slightly more than 1 astronomical unit away from the Sun. Pluto's largest moon, Charon, was also named after a woman. Remember the romantic story of Venetia, the English girl who in 1930 named the object we now know as Pluto? Well, it seems that romance is quite common among trans-Neptunian objects, because Pluto's moon, Charon, has a similar story. In July of 1978, the discovery of a satellite orbiting Pluto, which was still considered the ninth planet of the solar system at the time, made headlines. Observations and calculations by astronomer James Christie at the U.S. Naval Observatory in Washington indicated the existence of a massive moon very close to the planet. It was a significant discovery, and Christie wanted to exercise his right as the discoverer to name the new arrival after his wife, Charlene. His colleagues, however, leaned towards a more classical name like Persephone, the wife of Hades, the Greek equivalent of the Roman god Pluto. A compromise was reached. The satellite would be named Charon after the ferryman who transported souls across the river Acheron, one of the 5 mythical rivers surrounding Pluto's underworld. The name also honored Charlene, as the first 4 letters CHAR matched her name. The name was accepted by the International Astronomical Union in January of 1986. Hey guys, just a moment before we continue. Be sure to join the Insane Curiosity channel. Click on the bell. You'll help us to make products of even higher quality. As of today, 278 moons. Imagine this. In 1900, only 22 natural satellites in the solar system were known, including our moon. By 1950, the total had risen to 29, but by 1970, it was still 29. In 1980, with the first data from the Voyager missions, the count reached 41. By 1990, with Voyager 2's flybys of Uranus and Neptune in 1986 and 1989, the number increased to 58. By 2000, thanks to the widespread use of CCD sensors on ground-based telescopes, the count reached 87. Today, as of October 2024, thanks to surveys conducted from Earth with large telescopes and from space with space telescopes, the moons of the major planets have grown to 275, not counting those found around dwarf planets and asteroids. Except for Mercury and Venus, all the planets have their own natural satellites. The red planet, Mars, has 2 moons called Phobos and Deimos, the latter being the smallest found to date, although new moons and record candidates are being discovered all the time. Jupiter has 95 known moons, including Io, Europa, Callisto, and our solar system's largest moon, Ganymede, which is even bigger than the planet Mercury. Saturn also has 146 moons, with the solar system's second largest moon, Titan. Uranus has 28 moons, and Neptune has 16. In total, 16 out of 275 moons exceed 621 miles, or 1,000 kilometers in diameter, and 4, Ganymede, Titan, Callisto, and Io, are larger than our moon. The smallest, well, they are little more than half a mile, or 0.8 kilometers. Pluto is technically a binary system. Let's start with a fact. Pluto may have lost, perhaps undeservedly, its status as a planet, but it rightfully holds the title of the only large binary object in the solar system. Pluto and its large moon, Charon, share a characteristic that, to a lesser extent, only another pair does, Earth and its moon. What is it? Well, in the rest of the solar system, the mass of satellites is negligible compared to the planet they orbit, with a ratio never exceeding 1/4000th. Think of Jupiter's massive satellites compared to the enormity of their parent planet. Our moon and Charon, however, are outliers compared to other satellites. The moon has a mass equal to 1/81 of Earth's, and Charon's mass is up to 1/9 of Pluto's. The significant mass of the 2 satellites shows its effects on the gravitational pull that the moon and Charon exert on Earth and Pluto, respectively. When a planet has a mass thousands of times greater than its satellites, they orbit without significantly disrupting the planet's motion. However, Earth and Pluto are forced by the relatively large mass of the moon and Charon to rotate around a barycenter far from their geometric center. Planet and satellite move like 2 skaters spinning around while holding hands. In the case of the Earth-Moon pair, the common center of mass is still within Earth, about 2,900 miles or 4,700 kilometers from the planet's geometric center, and about 930 miles or 1,500 kilometers from the surface. In the case of Pluto and Charon, the center of mass is in space between the two bodies, about 590 miles or 950 kilometers above Pluto's surface. This allows for the Pluto-Charon pair to be called binary. The most accepted definition for a binary or double planet is that the barycenter of the pair must be outside the more massive body. Using this test, Pluto and Charon are a double planet, while Earth and the Moon are not, though just barely. Uranus and Neptune are not gas giants as commonly believed. They actually belong to a separate category of giant planets called ice giants. This is because less than 20% of their mass is made up of hydrogen and helium. True gas giants like Jupiter and Saturn are over 90% hydrogen and helium. In 1952, science fiction writer James Blish coined the term gas giant, which was used to refer to the large, non-rocky planets orbiting in the outer solar system. However, since the late 1980s, with data collected during Voyager 2 flybys, the compositions of Uranus and Neptune have been considered significantly different from those of Jupiter and Saturn. For this reason, scientists increasingly classify Uranus and Neptune as ice giants to distinguish them from gas giants. Jupiter and Saturn are primarily composed of hydrogen and helium, with large mantles of metallic hydrogen, which acts like a metal due to the pressure and temperature inside these planets, and only small cores of rock and ice. That's why they are called gas giants. They are mostly gaseous with very little rock and ice. Uranus and Neptune contain some hydrogen and helium, but also heavier elements like oxygen, carbon, nitrogen, and sulfur. Beneath their relatively thin outer shells of hydrogen and helium, the mantles of these planets are largely made of compressed, slushy water and ammonia. The rocky and icy cores of the ice giants are also proportionally larger than the amount of gas they contain, unlike the gas giants. Additionally, Uranus and Neptune, about 31,000 miles or 50,000 kilometers in diameter, are significantly smaller. All these differences, though small, suggest a somewhat different origin for the large planets of the outer solar system. Jupiter's largest moon has an ocean with more water than Earth. As far as we know, there might be 8 oceans in the solar system, but Earth is still the only planet with liquid water on its surface. The other oceans are found beneath thick layers of surface ice. Surprisingly, our planet ranks only 5th in terms of ocean volume. The largest ocean in the solar system is on Ganymede, Jupiter's largest and most massive moon. Confirmed in 2001, its volume of water buried under a 95-mile or 150-kilometer thick ice crust is estimated to be 8 times greater than Earth's with a depth of 60 miles or 100 kilometers. Second in this ranking is Saturn's moon Titan, followed by Callisto, Europa, and Earth. Next are the oceans of Pluto, Triton, and Enceladus. Our ocean contains 321 million cubic miles or 1.34 billion cubic kilometers of salt water. That's a huge volume, considering all 7 billion people on Earth could fit into just 1 cubic mile. Surprisingly, fresh water accounts for a tiny 3.5% of all the water on our planet. Of this amount, only 1% is available for humanity. The rest is trapped in Earth's ice, mainly in Antarctica and Greenland. Space probes have visited all 8 planets. It's incredible to think about, but in less than 30 years, from 1962 to 1989, we completed the grand tour of all the planets in the solar system. The first to be visited after Earth, of course, was Venus. The American probe Mariner 2 flew by on December 14, 1962, passing 21,607 miles or 34,773 kilometers from the surface. The second was Mars, reached on July 15, 1965 by NASA's Mariner 4, which came within 6,118 miles or 9,846 kilometers. Then came Jupiter, flown by on December 3, 1973, at a distance of 82,178 miles or 132,252 kilometers by Pioneer 10, and Saturn approached on December 1, 1979 by Pioneer 11 at 13,000 miles or 21,000 kilometers. Voyager 2 reached Uranus on January 24, 1986, flying by at a distance of 50,600 miles, or 81,500 kilometers, and the same spacecraft arrived at Neptune on August 25, 1989, skimming its surface at 3,076 miles, or 4,951 kilometers. Moons around asteroids. We recently talked about the moons of the major planets, but over the past 30 years, even asteroids, both those in the main belt and trans-Neptunian objects, have started to show that they also have satellites. The first asteroid moon discovered was Dactyl, just about 0.9 miles or 1.5 kilometers in diameter, orbiting the asteroid 243 Ida, average diameter of 20 miles or 32 kilometers. The discovery was made possible in 1993 thanks to the Galileo probe. The second asteroid moon was found in 1998 around 45 Eugenia. By early 2004, the number of known asteroid moons had risen to about 40, thanks to discoveries made by ground-based telescopes. Satellites have been found around main belt asteroids, Trojan asteroids, and Kuiper belt objects. In 2005, the first triple asteroid, 87 Sylvia, was discovered with 2 smaller satellites. As of December 15, 2024, the following have been discovered: 103 near-Earth asteroids, 5 with 2 satellites each; 34 Mars-crossing asteroids, 1 with 2 satellites; 270 main belt asteroids, 1 with 3 satellites, 8 with 2 satellites each, 1 binary with dual comet designation; 8 Jupiter Trojan asteroids, and 142 trans-Neptunian objects, 2 with 2 satellites, 1 with 5 satellites. Okay guys, we're done for this time too. I hope that at least something has impressed you of all that has been said. Until next time.